Hi, Year 9, and welcome to Thursday's lesson this week, which is reaction rates and concentration. So today we're going to look at how concentration affects the rate of reaction. So something's more concentrated or less concentrated, how does that affect rate of reaction? And also we're going to look at how pressure on the rate of reaction affects how fast or slow the reaction happens. Looking at concentration of solutions and also the rate of reaction due to pressures. So to start with, it's a flashback to yesterday's lesson. Can you put those four animals and insects in order of surface area to volume ratio, smallest to largest? Go. Okay, hopefully you managed to do that. Let's look at the answers. These are the answers. The elephant has the smallest surface area to volume ratio, and that little insect there, I believe is a flea, has the largest surface area to volume ratio. So the smaller an animal gets, the greater the surface area to volume ratio is. So what does concentration mean? And what do you relate to that word? So pause the video now and can you write down for me what do you think the term concentrated means? And then what do you relate to that word? What type of general day-to-day things do you talk about when you talk about concentration or concentrated? Okay, so hopefully you've paused the video and managed to come up with a definition of what the term concentrated means. If you didn't, what do you relate to that word as well? Well, this is the answer. So concentration is the relative amount of a given substance contained within a solution or in a particular volume of space. So it's the amount of solute per unit volume of solution. So think about it in terms of squash. If you like quite a weak squash, you won't put much squash in, but you'll put lots of water in. But if you like a strong squash, a high concentration of squash, you'll put lots of squash in the glass with not as much water. So it means that there'll be more squash particles to water particles in a high concentration of squash than if, for example, you had a low concentration of squash, where there'd be less squash particles. So can you please have a go for me? Can you try and write out that definition of concentration in terms a 12-year-old would understand? So someone in year 7, can you try and write a definition that would make them understand what the word concentration means? Okay, hopefully you've managed to do that. So as you can see from this diagram here on the screen and what you're about to see in a minute during the live experiment is that we've got a conical flask and we've got this gas syringe attached to the conical flask. So the gas syringe is going to collect the gas produced here in the conical flask. So we're going to be using hydrochloric acid and changing the concentration. So 0.5 and 1 mole concentration. But instead of manganese dioxide, we're actually just going to use marble chips or calcium carbonate, and they release carbon dioxide in a reaction with hydrochloric acid. So we're going to use the same amount of hydrochloric acid as a control variable. We're going to use the same amount of marble chips as a control variable, but we are going to change the concentration of the acid 0.5 and then 1 mole. And then we're going to record the amount of gas produced every half a minute for 5 minutes. Okay, and so this little syringe will start moving outwards as the marble chips react with the hydrochloric acid.